understood which road to take. It's a fine line, and your decision makes a difference. Get it wrong, you'll be making a big mistake.
Hi, in this video we're going to talk about equations of lines. Okay, so why do we care about equations of lines? Well, an equation for a line will describe the relationship between x and y all along the line. I've given you one here. We know that this is x and this is y. Okay, and what our equation will do is tell me that the point 1, 1 is on this line, and the point 2, 3 is on this line. So why don't we just list all the points on this line? Well, there's actually an infinite number of points. I've concentrated on ones that I can read off exactly, but if I wanted to, I could come here and say, all right, what happens at a half? Well, it's a half and a fifth or something like that, okay? So remember that a line is made up of an infinite number of points, and it will go on for forever. So instead of having to list all these points because there's an infinite number, we want to come up with an equation that will describe the line. Okay, and if I told you right now that the equation to describe this line was y equals 2x minus 1, well, notice here are my y values, here are my x values. I said the point 2, 3 is on that line. Well, if I plug in 2 for x, then I should get 3 for y. Or if I plug in 3 for y, I should get 2 for x. So let's try it up here. First, let's plug in 2 for x. We would get that y equals 2. And now if I know x is 2, I'm just going to plug it in there. Minus the 1, I would get y equals 4 minus 1, which is 3. Okay? And what that tells me is that the point 2, 3 is on that line. And now I said similarly, I can plug in for y and solve for x. We don't do that as often, but we can. If I told you that y was 3, could you tell me what the x value is? Well, we would solve for x. First, we would add 1 each side. I would get that 4 equals 2x. Solving for x, I would divide each side by 2, and I would see that x equals 2. Again, this just confirms the same thing I saw over here, and that is the point 2, 3 is on the line. So now if I really want to know what the value is at a half, okay, which is what I mentioned before, I could plug in a half for my x. 2 times a half is 1, and I would get 1 minus 1, so y is 0. So actually at a half, this is my point here, 1/2, 0. Okay. Okay, so I can do that to find any value of any point along this line, and it's very important to keep in mind we're not just concerned about the ones that we can read off exactly, right, that are nice and neat, 1, 1 or 2, 3. All right, we may at times want to know every value along this line, including fractions and decimals. So what we're going to do in this video is talk about how do we come up with this equation for this line. And now in this video we're going to concentrate on slope-intercept form. The slope-intercept form of an equation of a line looks like this: y equals mx plus b. Now we call it the slope-intercept form because m is our slope. And the way I like to remember that is M stands for mountains, and we ski down. This is me. All right, a mountain slope. So M is our mountain slope. And actually, I just fibbed a little because I only fall down a mountain slope. All right, so this describes our slope of our line. And again, we can think about the steepness. All right, just like we're thinking about a mountain slope, the steepness of the line it will describe. And then this is the y coordinate of the y-intercept. All right, what is the y-intercept? Well, that's just a fancy way of saying the point where the line crosses the y-axis. And I probably shouldn't say crosses, I should just say meets or intersects, right? Intercept intersects the y-axis. Right? If we go back to our graph we were just looking at, we would come up with a slope that would describe this line. It would tell us how steep it is. And then our y-intercept would be right here. Okay? It is the point where this line crosses the y-axis. And this point right here is 0. Sorry, my pen's not on right. -1. Okay? And notice that I said it is the y-coordinate. So it is -1. Why is it the y-coordinate? Well, it can't be the x-coordinate because something funny about a y-intercept. The x-coordinate is always 0. That's what it means to have a y-intercept. The x-coordinate is 0. So in this case, I would have the steepness of my line, and then my intercept, my y-intercept should be -1. And if we go back and look at our equation, sure enough, we see that it's -1. So plugging in for B really is that simple. We find the point where our line crosses the y-axis and we take the y-coordinate, which is -1, and simply plug it in. So how do we find our slope? Well, if we can find B by reading it off the graph, how do we find our slope? Well, from a graph, we use rise over run. Okay. Now, the way this works is we pick 2 points, and preferably we're going to pick 2 points that we can read off exactly. It does not matter which 2 points, and I'll show you that in a second. So I'm going to pick these 2 points, my 1, 1 and my 2, 3. And my rise is the number of units I go up or down. So if I go up, it's going to be a positive number. If I go down, it's going to be a negative number. But if I'm going from here to here, I'm going to go up 1, 2 units. So that means in this case my rise is a 2, and now it's positive because I went up. And now I'm going to calculate my run. Well, my run says that if I went up to here, if I want to run over to the point, right, how many units does it take? Well, it takes 1 in this case. Again, to the right is positive, to the left is negative, so I'd have 2 over 1. Reducing that, we would get just 2. And notice when I gave you the original equation, what is sitting there in the slope position? That is a 2. Now there's a couple of watch-outs here. To be in slope-intercept form, y needs to be isolated all by itself. Okay? In other words, if I had the equation 3y equals 2x minus 4, my slope is not 2. I have to first isolate y. Well, we can do that simply by dividing every term by the 3. We would get y equals 2/3 x minus 4 over 3. And now I'd be ready to tell you that 2/3 is my slope, okay? And -4/3 is the y coordinate of my y-intercept. So my y-intercept would be 0, -4/3. Okay, so the watch out here is before we start reading off the slope in the y-intercept, we have to have it in slope-intercept form. And the key thing about slope-intercept form is that y is isolated all by itself. It can't have another term over here, and it can't have a number in front of it. All right. Now going back, remember to find the y-intercept, we simply read it off the chart, the y-coordinate of our y-intercept. And to find our slope, it's rise over run. Now I picked these 2 points, but just to show you we can pick any 2 points, I am going to now take this one, our y-intercept, it doesn't matter, and this one. Again, if we do rise over run, so the number of units we rise up, 1, 2, 3, 4. All right, the number of units we'd run over from here, 1, 2, I would get 4 over 2. And notice that if I simplify that, I get a 2. That is exactly the same thing as we got the first time. So it does not matter which 2 points you pick on the line. And you're going to want to try to pick points that you can read off exactly. If I pick like this point and this point, I'm going to drive myself nuts trying to figure out, okay, how many units is that up? How many units is that over? Okay. All right, so we've talked about slope-intercept form, y equals mx plus b. And now that is the form that we use when we want to construct an equation of a line from a graph. Okay. There's another time that we use that as well, but we're going to do two examples of constructing an equation of a line from a graph first before we talk about the other time we use it. All right, so here is a graph. We're going to start with slope-intercept form, y equals mx plus b. Notice that we just need to fill in m and we need to fill in b. So first I'm going to locate my y-intercept, which is right here. That point is 0, -2, and that's the y coordinate is going to be my b. Okay. All right, so I can go ahead and say, all right, this is going to be mx minus 2. And now I just need to find my slope. Well, I picked that point. I'll just pick another point. Again, we're just going to pick off one we can read off exactly. Pick that one. And now we do our rise over run. Okay. How many units to rise up? 1, 2, 3. I went up, so it's going to be a +3. How many units to run over? Well, I went to the left, so I know that this is going to be negative, and it's a -1. So I get -3. All right. And so to finish this out, I would get y equals -3x minus 2. And one way to check yourself is notice that my line's going downhill here as I go from left to right. We're going downhill. If you're going downhill as you go to left to right, you should have a negative slope. In the first example we did, we were going uphill from left to right, and notice that we had a positive slope. Okay, so that is a way to double check yourself. Another thing to note is if we depict, say, this point and this point way up here, rise 1, 2, 3, 4, 5, 6, run 1, 2, but I went to the left, so it's negative. Simplifying that, I would have -3. So again, it doesn't matter which points we select. And it's important to remember that when you're writing an equation of a line, you have to have it in y equals mx plus b form. And so this is your answer. You wouldn't say slope -3, y-intercept -2. This equation is your answer. We're looking for the equation. In example 1, they ask us to write an equation for a line with a slope of -3 and a y-intercept of 0, 7. So we're going to start with y equals mx plus b. Slope of -3, don't overcomplicate that. This is my slope, so my -3 is going to go in there. And they tell me a y-intercept of 0, 7. We're going to take the y coordinate. Don't overcomplicate this. That's going to go in for b. And so I can write this equation pretty simply as y equals -3x plus 7. Okay? And now again, remember, they have to give me the slope and they have to give me the y-intercept. Now sometimes they may just give you a point and not tell you it's the y-intercept. So write an equation for a line with slope of 4 passing through the point 0, -7. Now if it is not the y-intercept, you're going to have to do something different. But if it is the y-intercept, you're going to notice right here, notice that if x equals 0, we have the y-intercept. So if you're on your toes and you know to look for a 0 here, you'll have the y-intercept and you don't have to do as much work as if you don't. So y equals mx plus b. Again, it says slope of 4, so that's going to go in for my m. And we know, even though they didn't tell us it was the y-intercept, we know that this is the y-intercept because x equals 0.
There is a fire